Hi guys. Today we're continuing with our systems of three variables. So just a reminder, that means that there's going to be three equations and that your final answer should be an ordered triple. Yesterday we did a substitution problem that was pretty basic. It was kind of like already solved for you for the first answer, and then you just had to substitute it back in to find the other two answers. Today, day two, we're going to do another substitution problem, but it's going to get a little bit more intense. So here's our first example. Notice that I used different colors for each equation, and the reason why I did that was to just kind of help me keep track of which equations I was working with. It's not required, but I find color very helpful in these problems. Now I can tell that this problem is set up to use substitution because if you look at the bottom two equations, they're both solved for a variable. My purple equation is solved for the letter z. The z is all by itself, and my green equation is solved for the letter y. The letter y is all by itself. So that means that this problem is trying to lead us towards using substitution. I'm going to start with the bottom equation because I noticed that the bottom equation is the only equation that has two letters instead of three letters. Everything else has an x, y, and a z, but the bottom equation only has an x and a y. The bottom equation has the letter y written in terms of x. If I can get the middle equation to have the letter z written in terms of x, then I'm on the right track. So here's what I'm going to do. I'm going to take my green equation, and I'm going to substitute it into my purple equation, where the letter y is. So I've replaced the letter y with a 3x minus 13. And I'm going to go ahead and simplify this right now because it's a little bit too much math there for me. So I'm going to distribute my -4, and I'm going to combine like terms. And what I now have a new equation for z that only has the letter x in it. It no longer has an x and a y. And so here I have the letter y is written in terms of x, and the letter z is also written in terms of x. That means wherever I see a letter y, I can replace it with a letter x. And wherever I see a z, I can replace it with a letter x. And so I can get a single equation with just the letter x in it. And that's going to be our top blue equation. So in our top blue equation, we have letter x here. I'm going to substitute where the y is with this 3x minus 13. So it won't be a y anymore. Now it'll be an x. And I'm going to substitute where the z is with this -10x plus 52. So instead of a z, that one will also be an x. And what that gives me, again, is one equation that only has one type of variable in it. The only variable in this equation is the letter x. That means I'm ready to find my first answer. It's a lot of numbers, but only one kind of variable, just the letter x. So I'm ready to find my letter x. So I'm going to do some distributing. If I'm going too fast, remember you can always pause the video to write all this stuff down or to try it on your own and then come back and check your answer. I'm going to combine like terms. I'm going to minus my 52. And divide by the -11. And so I found my first answer now. My first answer is x equals 5. Substitution problems are fantastic because to find your other answers once you've found your first answer, it's a little bit more basic math, something that you could potentially do in your head. And so to find my other answers, what I'm going to do is I'm going to take this 5 for my letter x, and I'm going to substitute them into these equations where like the y was written in terms of x and the z was written in terms of x. So I'm going to take my 5, I'm going to put it in my green equation. And maybe you can do this in your head. 3 times 5 and then minus 13. And I get my second answer. My second answer is y equals 2. Now that we know our x and a y, you have two options. You can plug in this 5 for the x over here, or you can take the 5 and the 2 and plug them into the original purple equation. It doesn't matter. You should get the same answer no matter which of those you do. I think I plugged it into this one, so I'd only have to plug in one variable. And again, maybe you can do that in your head. -10 times 5 and then plus 52. And I get that answer is also 2. So this was lots of substitution. And I could tell it was substitution again because my variables were alone. And you want to try to make your alone variables have only one variable on the other side. So my y I already did, and then I forced my z too. Then I could get a single equation with a single variable, and everything after that is just, it's more substitution. Don't forget your final answer is an ordered triple, x, comma, y, comma, z. This concludes our last substitution video with 3 variables.